Okay, let's talk the basics of meters, measuring voltage and resistance. We're going to leave current till a future session. And meters come in all shapes and sizes. As you can see in front of here, we have two different kinds of meters, or two different makes of meters. This is a Fluke 77 meter, a little bit more expensive meter. And this is a very inexpensive Tack Life meter. And meters vary in quality, all kinds of different things. So they come in all shapes and sizes. Some are better than the others. The things that you see coming off of here, you have to be able to connect these to a circuit some way or other, and these are called meter leads, and we'll talk about those a little bit in our session too. So let's get into it right away. Let's talk about measuring voltage first. And that's the easier of the two things to be able to do. Let's put up a circuit here so we can take a look at what we would like to measure and do it. This is a very simple circuit with a power supply, in this case a battery. It looks like we're saying this is a 10-volt battery, and we have a complete circuit that goes around here with wires connecting these two resistors together and comes the whole way back to the negative side of the power supply, and that's what it takes to complete a circuit. We would have current flowing in the circuit. The voltage is the force that's pushing the current around the circuit, and the resistance is limiting the current that's in the circuit. So what we're interested in measuring there. So this is a DC voltage, which means if I looked at it with a scope to see the shape of it, it would just be a straight line. It's at 10 volts. That's not significant. So if I want to measure something with a meter, these meters are battery operated, so they're isolated from earth ground. Scopes aren't, and that's a big deal. So you can't get yourself in trouble as easily with a meter as you can with a scope based on the earth ground. Once again, that's a future topic that we'll have to deal with. But for the most part, if you want to measure a voltage at a part in a circuit, you take one lead of the meter and you place it here, and you take the other lead in the meter. If you want to measure it right across this resistor, we would press it here. So the red lead usually is hooked to the positive side of the meter when you're measuring DC voltage. There's a plus and a minus side, and the black lead is usually connected to the negative lead of the meter, and that's definitely the way we have it on our Fluke meter, and it's there. You also can measure from test point 1 to ground. You would be measuring across these two, the voltage across these two components. We could measure directly off a battery and do it. We usually keep the black lead on the ground side and the red lead on the plus side. That way the meter will indicate to us whether we have a plus or minus voltage. I don't have an AC voltage source with me, but AC voltage is a little bit easier to measure because there is no plus and minus side, but we still keep the leads conventions as red for plus and black for minus. Okay, let's go back to our circuit then. I have this meter, and you can see that we have to switch it around to V to measure DC voltage. In this case, it measures V with a straight line across there. That's indicating DC voltage. If I wanted to measure AC voltage, I would turn this and go to the AC selection, which looks like a sine wave, which is the most common AC voltage. But we're measuring a DC voltage. We're going to put it back there. The red wire goes to the plus side of the lead, and you notice it's colored, so you can match the colors up. And the black lead goes to the common or the negative in our circuit. So I'm going to follow these leads here in our circuit, and we can see that we have one over here and we have the black lead over here. So I'm bringing a power supply in to this breadboard from the outside world, and I have a DC voltage on there, and it's set for 10.1 volts, and we're showing 10.04 on our meter, and that means that we've taken a voltage. I could move this to another supply that I have coming in here in sort of the center of the board, and this is coming from another piece of a test equipment called a Analog Discovery 2. This is the V plus side, as you can see labeled here, and when I put my meter lead on there, it measures the voltage there. I'm going to put this back in here, and just to verify that this is true, I'm going to switch the voltage on the power supply. I'm going to alter it, turn it a little bit higher, and you can see my meter measuring more. Now, my power supply says 12.16 volts, and my meter is reading 12.10 volts, and most people would say, well, what's right? What's the most accurate? And I'll say, I don't know. Just like you, I don't know. And what you end up having to do is have some source that you know is dead on to the voltage you want, and then you calibrate your instruments to that. So if I was working at somewhere where I'm measuring stuff that's measuring weight out by a voltage, this meter, I would have to get it calibrated every so often. I'd put it on, hook a standard up to it, and I'd adjust internal pots to get this meter to read exactly the standard voltage it was there, and then I would know what I'm trying to read. So that's how you measure voltage. There's other settings on here. We'll talk about those in future things, but I think for now we got that across. Now, the other meter that I have over here is measuring resistance, and that's this little symbol that looks like an omega, and that's the symbol for resistance. Might be a little hard to see in our video, but it's there. So the one thing with resistance is you want to measure it. You can only measure it when there's no voltage or current flowing in the circuit. So you have to have the power off, and to get an accurate resistance of a component, a lot of times you have to pull it, at least one side of it, out of the circuit, make it out of the circuit. So in our case, we have what I call a resistor network. It's an IC sitting here, and this resistor network, let's take a look at what happens with a resistor network and how you can figure out what the resistance of it is. Here's a pinout in the center. This might not be the exact part number, but this pinout represents it. And you can see in the top right corner is a common part between all these resistors in the resistor network. So I have the black side of my lead connected to that from my meter, and then I can move my meter to each of these other pins, and I'll measure the resistance from that common and across that part. Now remember, I told you you can't have any power hooked up to it, so let's go back to our circuit. First thing I have to do is make sure that I change the position to ohms to measure it. I also have to make sure I have no power connected to the circuit, and I don't in this case. And then I got to get my meter leads connected up so I can measure it. These little parts here are just to get my meter leads on there pretty easy without them falling off and doing it. And you can see I have the black lead up in the top corner, that's the common bus, and then I measure the resistance across one resistor, and this is a 1K ohm device. When I hook this up, I can see that I'm reading 0.998 ohms, K ohms that is, and that's 998 ohms, and that's well within the tolerance of the part that I have here, so that I know that I'm measuring the correct thing. Pretty cool stuff. Remember, this meter can do resistance also. Both of them can do the same thing. Most of the digital voltmeters have very similar measurement capabilities. Once again, we'll deal with them in the future.